Good morning, everybody in WA, where it's a bit earlier, and over here on the East Coast. This morning we have the Managing Director of Akora Resources, Mr. Paul Bibby, to give us an update on the Becky Soper iron ore project in Madagascar, with specifically some discussion around the most recent high-grade iron results and testing results. So we'll also have time for some questions at the end of this presentation. Thank you, Paul.
Very much. Thank you, Peter. Good morning, everybody. Today's screenshot for Akora is showing three images. The one in the top left-hand corner is some massive outcropping on the Becky Soper site. You can see those rocks, high grade, 67% iron ore in front of that truck. It's almost the size of a truck. The other two images I thought I'd show today is from the community project, which we completed in November, December of last year, where we provided the community of Tanna Marina clean water. So we installed the water tank, the solar powered pump, and that now distributes water across the Tanna Marina village. The first time they've had fresh, clean water, which is a wonderful thing. And they are very grateful for what we've done. So getting back to Akora Resources, the Becky Soper project, where we've got DSO high-grade iron ore. We all understand the importance of the forward-looking statements and the competent person statements. What attracted us to Becky Soper, our flagship project, was the outcropping iron ore and the high-grade weathered zone, which we saw in the trenches and the pits. The images on the left-hand side. 66.7% iron ore in the outcropping rocks on average, and in a drill hole near this pit in the southern zone, 66.1% iron, so DSO quality. Becky Soper, as we know, is some 250 kilometres from the port of Toliara in the south, central south of Madagascar. We also have our other projects on the east coast. Becky Soper is our choice because we see that being a low-cost DSO startup to operations where we focus initially on the high-grade outcrop and the surface iron mineralisation. We've now completed 63 drill holes, totaling some 6,200 metres along the strike, which you can see there on the right-hand side image, the green dots being the completed holes. This has confirmed the iron mineralisation continues below the high-grade outcrop, which was the objective, and very pleasingly that's the case. Now we've found iron mineralisation continuing at depth to 300 metres down dip along the 6 kilometre strike, at widths of plus 650 metres and true thicknesses up to 105 metres across and down dip. We've only drilled some 30% of the 6 kilometre strike. So this is indicating potential for a significant resource along the total Becky Soper 6 kilometre strike, which we'll be reporting on in mid-March of this year. Previously this year, I spoke about the central zone, those drill holes there in the yellow square, looking on the right-hand side at that magnetic intensity map. Today, we're going to look at the northern zone, where we've got some 13 drill holes for 1.2 kilometres of drilling. 9 of the drill holes are shallow, so less than 73 metres, and 4 are deep holes, averaging 200 metres, with the deepest going down 261 metres and intersecting iron ore at depth. So as I've mentioned, depths, so 300 metres down dip in those northern zone drill holes, widths of plus 200 metres, a true thickness up to 105 metres, so quite a significant iron formation, continuing at depth and dipping to the west. What we're seeing in the northern zone, and you can see from that very strong magnetic anomaly there where we've been drilling into in the northern zone, the mineralisation is continuing along 1.5 kilometres along strike, suggested by the magnetic anomaly and by the drilling. The next slide shows the northern zone cross sections. What we see here is the ore body is dipping to the west, true widths of 67 metres on the left-hand side and 105 metres on the right-hand side, and down depth lengths of some 300 metres. So quite a significant iron formation. We're seeing high grade, 64% iron near surface from the assay results. So this is potentially DSO material. Drill hole 1, just under 7 metres at 64.7%. drill hole 19, just on 5 meters at 64%, and drill hole 24, 4 meters at 63.7. So all very good grades. The mineralization is open from surface, as you can see there, and ideal for an open pit mining operation. I've highlighted drill holes number 1 and 19 because we're going to do some discussion around the processing trials on those 2 particular drill holes, which we see to be representative of the upgradability of the iron mineralization in this northern zone. So in the northern zone, focusing on drill hole number 1 and using wet limbs, we had an average grade of 62.8% down to 50 meters in that hole. So looking on the left-hand side, we've got 3 composites there. The surface composite to 8 meters, potentially DSO, grading some 61% iron. Composite 2, which is the massive material, grading around 50%. And then at 40 meters, composite 7, coarse disseminated iron, grading around 47.5%. These have readily been upgraded at 2 millimeter crush and using magnetic separation limbs to produce, on average, a 62.8% iron fines product. So better than benchmark grade after crushing to 2 millimeters. Low in silica and alumina, 95% recovery of the iron, and a 68% mass yield. So what that means is the mass yield. For each 3 tons we mine, we produce 2 tons of iron ore fines product, grading 62.8%, low phosphorus and low sulfur, as you can see there. We also did some Davis tube tests on the material in Becky Soper number 1, drill hole 1, the same composites, average head grade in that hole from 0 to 49 meters of 45.1% iron. And the Davis tube testing, again, a magnetic separation process at a 75 micron, so a relatively coarse sizing using the assay pulps, upgraded to 69.9%, 0.6 silica, 0.7 alumina, 004 phosphorus, and 008 sulfur. So very high grade material. And from the reading that we're doing on the green steel, this material is most suitable for direct reduced iron feed grade, which is what they'll be looking for when they're producing iron and steel using natural gas and potentially hydrogen down the track to make what they call green steel. So a premium high-grade product at a relatively coarse grind size of 75 microns. We're not having to we're not having to grind to 15 or 25 or 40 microns. We're getting these grades at 75 microns, and potentially we could get these grades at a coarser grind size than 75, I believe. So looking more closely at drill hole number 1, which intercepted iron ore from surface to 70 meters down hole. The wet limbs, the image on the left-hand side, grading 62.8% iron on average, and the Davis tube tests across those composites, but going down to 70 meters, is 69.9% iron. So we believe from these 2 process trials that we've conducted that this is representative of the mineralization in the northern zone, and we'd expect similar limbs testing results, product grade results at a 2 millimeter crush across the northern zone. So what we're seeing, as we saw in the central zone, the assays and product upgrading trials appear to be very consistent and reproducible along and across the strike, and certainly at depth through the iron formations that we've intercepted in the drilling program. Looking more closely at this, particularly the iron, which is the image on the upper left-hand side, the head grades from around 30% to 60%, the surface one at 61% is potentially DSO. The others are readily upgrading, as you can see from that graph, to better than benchmark grade with limbs at a 2 millimeter crush and 70% iron using magnetic separation at a 75 micron size. Not only is the iron upgrading quite pleasingly, the silica, alumina, and other impurities are reducing dramatically with a crush to 2 millimeters. As you can see, the silica from an average grade of 17% to 4.3%, and then 0.6% at 75 microns using the Davis tube. The average of these results is 0.004 phosphorus and 0.008 sulfur, which I think we'll find is some of the cleanest high-grade iron ore at a 75 micron sizing and after magnetic separation. As I've mentioned before, we're now anticipating 5 iron products from the Becky Soper project. In the first years, say years 1 to 10, producing high-grade DSO plus 65% lump and fines from the outcropping and the very high-grade weathered zone, where we're seeing grades at 68 and 69%. So this is going to be conventional shovel, truck, crush, screen to produce lump between 6 and 35 millimeters, fines between less than 6 millimeters, and then shipping that product out. As we know from DSO projects, that is a very low capital cost to get a startup and a low operating cost to produce DSO lump and fines. And then beyond year 10, plus or minus a couple of years, move into crushing the medium grade materials, the 60%, the 52%, the 42%, and producing a fines product from the weathered zone. That should upgrade readily, as we've proven, to 65% iron, and at depth we're seeing it to be upgrading to better than 62% iron, as we saw earlier with the results from Becky Soper 1. So first 10 years, high grade DSO lump and fines products, plus 10 years. We can use some money raised from that first 10 years of operation to invest in a initial processing circuit to crush the material and produce better than benchmark grade fines from Becky Soper material. The 5th product, which we're learning more about from doing the Davis tube tests at 75 micron sizing, is that we're producing a 69.9, 70% iron product at that sizing after magnetic separation. This material is certainly suitable for DRI feed to make pellets for the green steel activities as the iron and steel decarbonisation happens across the industry, where they start using natural gas and hydrogen rather than coke and coal to reduce their CO2 emissions. So as that improvement in iron and steel making technology happens, Becky Soper is going to be very well placed to provide a 70% iron product. Certainly from the trials that we've done across the central and northern zone so far, we've also done a few trials at 15 to 25% lower grade head grade material, and this is also upgrading to 69.9% at a 75 micron size. And those trials on the northern zone across several holes in the northern zone, number 1, 2, 19 and 20, 69.9% iron, very low silica and alumina, 0.002 phosphorus and 0.03 in sulfur. Very suitable for that future material for the manufacture of green steel. So looking more closely at the northern zone, in summary, it's a significant iron formation, open at depths to 300 meters down dip. It was the first area where we did the deep drilling, and pleasingly we hit some quite massive iron formations, and it's dipping to the west. It's confirmed over 1,500 meters on the main strike length in the north. It's identified a cross strike and true widths of 100 meters, which is going to make it 70 to 105 meters, which is going to make it relatively straightforward for mining. So the northern zone, in conjunction with the central zone, is now starting to look to be forming part of a substantial iron resource along 3,300 meters of the main strike length. The products possible from the northern zone, the iron ore grades at 64% at surface, potential for DSO, 62.8% iron, high grade after magnetic separation at a 2 millimeter crush with low impurities. And as we've seen with the Davis tube test results at a 75 micron size, 69.9% iron, premium high grade at that sizing, extremely low impurities, as I've mentioned, silica, alumina, particularly phosphorus and sulfur, all very good low grades. Potential DRI product for the future green steel industry. From the information I've been able to source, DRI pellet grade is anything better than 67% iron. So quite clearly, at a 75 micron grind, a 70% product is going to be achieving a premium over, above that grade. And it's quite possible, and we should look at doing some trials at a coarser grind size, 100, 125 microns, to see what iron grades we get and impurity grades we get, because that could certainly produce, I would believe, better than 67% iron grades. The background for this last slide is the wet limbs product at a 2mm crush from Becky Soper 1 that grades 63% at 40 meters below surface in the northern zone. So a lovely clean product at 40 meters below surface. Looking at the iron ore price in the sort of end of January, early February, the 62% iron benchmark price is now at $145 a ton. So that's up some 12 to 15% from what it was at the start of January. The 65% iron product is at $175. And for the first years of production at Becky Soper, where we're looking to produce lump and fines, over and above that $175 price, you get a lump premium, which is normally $15 to $20. So quite a good way, I believe, to start an operation at Becky Soper going forward. So thank you for your time. And as before, we've done the central zone now, we've done the northern zone. I'm currently working on the southern zone where there's 38 drill holes. We will report on that within the next 2 weeks, and then that will all build up towards producing the initial JORC resource for Becky Soper, which we plan to have out by mid-March. So thank you very much for your time and for your support.
Thank you, Paul. Another really good coverage of this zone. All the parts of Becky Soper are really seem to be showing much better potential and much better results than we could have hoped for at the start. Certainly. Just a couple of questions coming through here. I'd like to just start off with the general iron ore price. It's had a really good run since it bottomed out back in October, November, and it seems that we're returning back to a longer-term uptrend. Do you see that sort of pricing environment stabilising?
Well, look, the pricing we've seen at the start of 2022 has been tremendous. It's been steadily building through January, where we're now seeing, the $145 at the moment for the benchmark grade, which is a tremendous price, and better for the higher grade, because the steel industry prefers to be getting 65%. It's not in massive supply, but you get that extra premium of $30 if you can produce the higher grade material. The demand in China, but elsewhere across the world, with the infrastructure projects that are happening, whether that be India, Europe or Australia, the demand for steel is very strong. And my expectation is that should mean that the iron ore price should also remain strong going forward into 2022.
And Paul, on the iron ore price, what's the sort of pricing rates for DSO material at the sort of anticipated grade that you'll be looking at Becky Soper?
Okay, so the benchmark grade, if you produced a 62% DSO, you get 145. So some of the results, as we can see on this last slide, we're seeing an average of 64% iron at surface. So we're going to get more like 165 to 170 US dollars a ton for that material, lump and fines. And as I mentioned, over and above, say, the 165 at 64% iron, a $15 premium for the lump material, which is needed to make sure the blast furnaces operate as efficiently as possible.
Those are some pretty good prices, and even at the current levels for the grade that you've got. You've mentioned potential low cost capex and low opex costs. The DSO, perfectly just dig it up and ship it.
Yes.
We've had a question here a little bit about the transport scenario, the roads, and we've had this question before, but just remind people about your outlook for transporting the material to port. Yeah,
so look, Becky Soper is, as you can see from the picture behind me, in a very remote location in south central Madagascar. We initially will need about a 70 to 80 kilometre all-weather road to get from site to join the national highway, highway number 7, and then complete the 250 kilometre trip to Toliara on the southwest coast where the port is. Trucking 2 to 3 million tonnes per annum along that road system there, we believe is achievable. The fuel maintenance, leasing of the trucks will be the same as it is everywhere in the world, but the labour costs will be dramatically lower in Madagascar than elsewhere. So I think we have an advantage in that case. And we're only having to transport downhill. Becky Soap is at 800 metres above sea level, going down to the sea level at Toliara, some 250 kilometres. We know in Australia, in Western Australia, there are several operations that are trucking one way more than 400 kilometres. So the cost won't be prohibitive. They'll be very competitive. And we need to do that study. And that is one of the first studies we'll be doing, along with some of the processing studies, once we've completed the JORC resource in March, and we can get people into Madagascar safely on flights. So maybe, say, from May, June onwards, we'll be getting people there to do the studies on the ground. So we better understand the logistics, practicalities, and any obstacles that might be there, and how they can be overcome, and what the forecast transport costs will be for that route.
And that's a very good point. I think we should be reminded of that the terrain there behind you could be in the Pilbara, and at 250 kilometres, that would be a relatively short distance if we were to compare it with some of the stranded iron ore projects in the upper and north of Western Australia. So when we're thinking about that sort of infrastructure, we're certainly not by any stretch going to be more impeded than some of the West Australian peers.
Exactly. I think if you think about the Pilbara, 400 kilometres would be a fairly typical distance. When I worked at Paraburdoo, that was 360 kilometres, I think, from the coast, 360 or 380. Tom Price is a bit closer. Some of the other projects were further away from the ports. Brazil, 700 to 1,000 kilometres is not unusual for the Vale and other operations in Brazil, from those projects to the coast. And the South African operation with Kumba, I think, is also a similar distance, possibly up to 1,000 kilometres, with some other operations a bit closer. But so the distances often are great. At Becky Sopa at 250 kilometres, we're certainly in a better position than many, I think.
And Paul, we started to talk about this green steel potential, which is now becoming more talked about amongst in the industry, and Andrew Forrest actually leading a lot of that conversation. Yes. How quickly is the industry starting to take up this theme, and what tangibly do you think you're seeing starting to happen to move the industry in some way towards green steel?
Yeah. Look, the first step is already happening, using natural gas instead of coke and coal to produce the DRI pellets. And then those pellets are fed into an electric arc furnace or into a blast furnace. So that is already happening. I'm not sure what percentage, but I think it would only be in the order of, say, 5 to 10% of iron and steel is made that way. There'll be an increasing push to invest the capital to produce more high-grade iron ore pellets, like from the material that we can see here, so that the CO2 emissions are reduced dramatically. In the initial phases, it will be using natural gas, and there are locations around the world where that is already happening, but there is potential for growth. And India, I think, has announced that they're going to be looking more and more towards high-grade pellets using natural gas initially. And then the move will be towards using hydrogen, replacing coke and coal, where they get zero emissions. And the expectation is sort of 2030 onwards. So the plans are for it to happen relatively quickly, considering the amount of investment that needs to happen, both in terms of the solar power, wind power generation, producing the green hydrogen, where we need a lot of water, but also the electrolysis activities, and then using that to convert product like we have here at Becky Sopa, 69% iron, into the DRI pellets, into the electric arc furnaces and the like, to produce green steel. So I think Sweden in Europe is one of the countries that's leading the way with this technology and has already produced some green steel for the transport industry. I think it's going into the production of some trucks. So I think it'll start to take off relatively quickly, but it's going to take a long while to replace all of the blast furnaces around the world with hydrogen to make green steel. But the opportunity for Becky Soper, where it's located, close to India, close to the Middle East, where there's plenty of gas, I think positions us well to participate in this DRI green steel activity.
That's pretty pleasing given the commentary that we're seeing. So we'll keep an eye on that theme. Paul, Central Zone, Northern Zone, Southern Zone, the total project, which is over 6,000 metres, now you're being able to separate it and look at these individually. What's next for shareholders to keep an eye on?
Okay, so I'm starting to receive the assays for the Southern Zone. There's a couple more holes to go, which I hope to get by the end of this week. So into the following week, my expectation, maybe the week after, because there's a lot of work. There's 38 holes to be reviewed and assessed and put together to understand the cross sections and the intercepts and the like. So in the next 2 weeks, the Southern Zone results for drilling and product trials will come out. And then we need to get all of the data together to submit to the resource geologist. And our expectation is to have a initial JORC resource by the middle of March.
Well, that's terrific, and a lot sooner than you expect, given the way the results are coming in, and given that they're showing more and more than what you may have hoped for at the start. So very encouraging.
Yeah.
All right. Well, I'll say thank you today, Paul, for that update, and thanks for everybody who's tuned in. If there are more questions to be asked, please send them through to me at peter@nwrcommunications.com.au. And Paul?
Well, just one, Peter, sorry, just one comment before I go. People will have seen on the news in the last few days, a cyclone has hit Madagascar. It's travelled across the sort of eastern coast in the central part of Madagascar, sort of headed towards where Becky Soper was, but as it headed towards Becky Soper, it lost its ferocity going across land. So there's been a lot of water and rain and some wind, but pleasingly no damage to the local village and to our at our site. But yes, certainly some high rainfall, but no real damage at all.
Yeah, sorry, that was on my list. I forgot to ask about the cyclone. All right. Thanks very much, Paul. Thanks, everybody.
Thank you, everybody. Thank you, Peter. All the best.